so take a look at problem number 17 from chapter 7. We have Bonzo and Ender from a science fiction novel. Science fiction, anybody know what it is? Ender's Game, Orson Scott Card. It's a good book.
It's also really racist.
Okay, well, we'll examine that at a later date. All right.
Really racist these days.
All right. So Bonzo and Ender are fighting in outer space. What's the significance of the fact that they're in outer space? There's no gravity. So the only forces that they'll experience are the forces they'll exert on each other, which means they are an isolated system, which is one of our requirements for conservation of. Now let's look again. Momentum. Yeah, we're doing conservation of momentum. All right. So when they push against each other, Bonzo flies off at the velocity of 1.5 meters per second. All right. So this is velocity of Bonzo. The velocity of Ender is equal to negative 2.5. I'm just going to put it as 2.5 here because I've already indicated the direction by the arrow. Okay? So without doing any work, without doing any calculations, which one has a greater mass, right? So this is part A. Determine which person has the greater mass. Which of these two has the greater mass? Okay, so I hear Bonzo. Can anybody explain why it's Bonzo, conceptually?
Because both of those are equal.
Yes, we know that, right, Brent. Both momenta have to be equal, and since Ender's velocity is greater, his mass must be less, right? So in other words, what we say is, we know that, let's redraw these vectors, but we'll draw blue vectors that are equal. So the momentum of Ender has to be equal to the momentum of Bonzo, right? And so since this is equal to M Ender V Ender, has got to be equal to M Bonzo V Bonzo, then we can take, let's just take, pick one, and we'll say, what is Ender's mass compared to Bonzo's? All right, so the mass of Ender is equal to the mass of Bonzo times the ratio of their masses, VB over VE. All right? Right? So we know that which one's got a greater number? Ender, okay? So we know that Ender's greater than Bonzo. So this whole expression right here is mass of Ender is equal to mass of Bonzo times something that's less than 1, isn't it? Okay? Velocity of, so that means that the mass of Ender must be what? Must be less than Bonzo's, okay? So that's just a conceptual approach, all right? And then part B asks us, we did our reasoning, determine the ratio of the masses of these two people. Well, look, we've already set ourselves up to do that, haven't we? All right, so we just take this equation right here. Mass of Ender is equal to mass of Bonzo over velocity of Bonzo, 1.5 meters per second, divided by the velocity of Ender. I think I said mass, but I meant velocity. All right, 2.5 meters per second. And so that's 3/5, right? So the mass of Ender is going to be equal to, these cancel out, so we still end up with a ratio of masses, right? And so this is a dimensionless ratio, so we got mass on both sides. 1.5 over 2.5, 3/5 or 0.6. So Ender's mass is 3/5 Bonzo's mass. And that is a fast one.